Alright folks, welcome back to programming Pong. And as you can see here, this is not a very good game of Pong. It's basically just a ball that sits on a screen. We programmed it over here with an ellipse that's filled with the color red. We set up something though. We set up the size of the screen. We set up the background to be green. We set up smoothing of our ellipse so it looks nicer. And we also set up a frame rate. This frame rate is going to refresh the screen and actually run the draw function every 24 times a second. Well, the problem is we're drawing the exact same thing 24 times a second, so it's really not interesting. So what we'd like to do is make the ball move. So let's redraw that. What we're going to need to do is change the position of the ball. So let's just move it to the right. This variable right here, or this number right here, is where the ball is in space. And you can see here if I mess with this number, if I change it to, say, 100, and I rerun the program, it moved over. Well, what we need to do is move that variable every time the draw function is repeated, so 24 times a second. Well, how do we do that? Well, we need to keep track of where it was and where we want it to be. So what we're going to do is create a variable for this. So we're going to say, we're going to call it ball x. So where is the ball in the x direction? Well, this variable doesn't exist yet. It doesn't do anything. We're going to create that variable, and to do that we're going to go up at the very start of our program and we're going to create a variable for ball x. Okay, ball x, oops. And ball x is gonna, where should we start it off at? Well, we started it at 50, so let's just do that. So this is where it'll be at the very beginning. But this variable won't work. We have to tell the computer what kind of variable we want it to be. And that's really important because the computer has to decide how much memory am I going to use? How much RAM do I really need to run this program? Where do I put this ball? Like, where is it on the computer? Well, you have to tell it how big it's going to be. Well, we have a couple choices. It could be an int, which is an integer, or it could be a float. A float is the variable we're going to go with, and a float is a decimal. So a float equals a decimal number. Why do we want to use a decimal number? Well, honestly, because we want the ball to be able to move, over half pixels and quarter pixels, so that it looks really smooth. If we use an integer, it's going to jump, and we've seen that before with our floating lines and things like that. So now we have a variable. So we've declared a variable. Okay, so this variable is declared, and we can go ahead and use it now. So down here, the program's going to actually know what we're talking about, and it's going to have created memory on the computer big enough to store information about ball x. So now, this program still will do nothing interesting. It equals 50, ball x equals 50, and when it draws the program, it's going to get drawn at 50, which is not very interesting. So what we'd like to do is move ball x. So every time we run the draw function, we'd like ball x to change. Well, let's do this. So ball x, and we're going to add 1 to ball x each time. So we say plus equals, and let's add 1 to it. This line of code says add 1 to ball x each repetition. Okay, so remember the draw function is being repeated. So ball x is going to go 50. It's going to turn into 51. Then this is going to get print an ellipse at 51. Then we'll see ball x added 1 to it, and it'll get printed at 52. So let's see what happens here. So we run our program, and you can see here a whole bunch of balls being printed 1 pixel over from each other each time. Okay, well, that's not that interesting, and it still isn't a game of Pong. So what do we need to change? Well, we need to make it so that the ball disappears, so it looks like one ball. And what we're going to have to do, actually, is redraw the background every time. So we're going to cover up the ball. So we're going to say background 100, 255, 100. So we redraw the background every time, and that'll make the ball look like this. So every time this function repeats, we're actually redrawing the green, then drawing the ball. Okay, well, this still isn't very fun. It's actually quite slow. So let's start jumping the ball a little bit faster. So we can change this to 5, and now it's going to jump by 5 pixels every time. So it'll look faster, right? But it looks jumpy, doesn't it? And of course it does. And of course it goes right off the screen, and now the ball is somewhere over here, doing nothing and not being very interesting. Well, so jumping by 5 is a really, really bad idea because it makes the program look jumpy. So what's another way we can speed up this process? Well, we can go up here to frame rate and actually speed up the frame rate of the game. So it won't look jumpy anymore, and we can actually get a quicker looking game. So let's maybe double this. Let's go to 44. And the ball will appear to move twice as fast. And in fact it does. Okay, it's still not quite as fast, and really you can actually tell it's still a little bit jumpy. So let's jump the frame rate up to a huge frame rate, and let's move the ball by half a pixel each time so it looks smoother. Okay, so now we jumped the frame rate up, but we're moving the ball much, much slower. Okay, we want the game to move a little bit faster so it's a little more entertaining. So let's change this 84 to something really fast. So we want to go maybe 3 times as fast as that. So let's, I don't know, put in something about 200 frames per second. This is well beyond what the human eye can see. You can see here it's actually not moving that much faster. Interesting. I wonder if there's an upper limit to frame rate. See if we put in like 800 frames per second. It doesn't appear to be moving much faster, does it? We must have found some upper limit on frame rate. And in fact, I don't know the answer to that. So we're going to go ahead and go to the processing API, and we're going to try and figure that out. So go to processing.org, and we're going to go to reference A to Z, and let's go to the frame rate function and see how that actually works. Okay, so let's see. They have an example here. They're setting up a frame rate of 30 frames per second. Okay, and they're creating a line, and then they're printing out what the frame rate is. The system variable frame rate contains the appropriate frame rate for the software. It's actually at 10 frames per second if you don't set it. Okay, that's good. That's why we use the API to find out stuff like that. So let's see. Let's check out the actual frame rate function and see if there's a limit. So it specifies the number of frames to be displayed every second. If the processor is not fast enough to maintain the specified frame rate, it will not be achieved. So frame rate 30 will attempt to refresh 30 times a second. It is recommended to set the frame rate in the setup function. The default rate is 60 frames per second. Interesting. So it looks like we don't really know how much higher we can go above 60. The API doesn't tell us. Interesting. So I wonder why we're seeing something so slow. Let's see if we go back down to 60 here. What do we get? Okay, still a pretty slow ball. Interesting. So we might be butting up against the processor limitations of the computer, or we're working against something that we're not aware of. Let's jump this back up so we can get a bigger step. Let's see what we can get here. Oh, we get the ball to move a little bit faster, don't we? Okay, let's see if we can jump that frame rate up just a little bit more. Now the ball's moving pretty quick. Okay, but we have a problem. The ball hits the side of the screen and then just keeps going. So in the next video, I'm going to show you how to detect the collision with the side of the screen and get the ball to bounce back.